Hello guys, welcome to this lesson. In this lesson, we're going to look at some sample examinable questions on quantum numbers. Sample examinable questions on quantum numbers. In our previous lessons, we learned about quantum numbers and atomic orbitals. We learned about the principal quantum number, which is denoted by N, the azimuthal quantum number denoted by the M, the L, the magnetic quantum number denoted by ML, and then the spin quantum number denoted by MS. But we didn't solve any question under that aspect. So in this lesson, we are going to look at 8 sample examinable questions on quantum numbers. So now let's go through them one after the other. In the first question, it says, write down the possible types of atomic orbitals for n is equal to 4. Write down the possible type of atomic orbitals for n is equal to 4. Is that okay? So if n is equal to 4, what are the possible atomic orbitals there? What are these atomic orbitals? These atomic orbitals indicate the angular momentum quantum number, which has a donation of L. And we said L can have value of 0, it can be 1, it can be 2, it can be 3, it can be 4 in that order. Is that okay? 0 represents an s orbital, 1 is a p orbital, 2 is a d orbital, 3 is f, 4 is a g orbital in that order. Is that okay? So how do we know the orbitals present in the fourth energy level or the fourth shell, that is n is equal to 4? So in our lesson on our azimuthal quantum number, I gave you the value range of 0 to n minus 1. So we use this value range to indicate the type of atomic orbital present in each energy level or shell. Is that okay? So in the question here, n is what? 4. So 4 minus 1 is equal to what? 3. So our value range becomes 0 to what? 3. For 0 to 3, we have the values 0, 1, 2, and then 3. Is that okay? Don't forget that 0 represents an s orbital, 1 represents a p orbital, 2 represents a d orbital, and then 3 represents what? An f orbital. So in the fourth energy level, or if n is equal to 4, we have all these 4 orbitals present. Is that okay? So since they are in the fourth energy level, we write them well. So it means in the fourth shell, we have the 4s orbital, the 4p, the 4d, and the 4f orbital. So these are the possible types of orbitals present in n is equal to 4. Is that okay? So to know the orbitals present in each energy level, we use the value range 0 to n minus 1. So if n is equal to 4, 4 minus 1 is 3. The value range from 0 to 3 is 0, 1, 2, 3. 0 is the s orbital, 1 is the p orbital, 2 is the d, 3 is the f orbital. So these are the orbitals present in the fourth energy level. And that is the solution for question 1. So in question 1, we have the 4s, the 4p, the 4d, and the 4f. Now let's move on to question 2. In question 2, we have which atomic orbital has the values of n is equal to 4 and L is equal to 2. You can pause the video and try. So which atomic orbital has value of n to be 4 and L to be 2? Is that okay? When L is 2, it represents what orbital? It represents a d orbital. Is that okay? So if n is 4, so 4, and then the orbital is 2, that is the d orbital. So this is the atomic orbital which has an n value of 4 and an L value of 2. Is that okay? So that is the answer for question 2 as well. And the answer is the 4d atomic orbital. Now let's move on to question 3. In question 3, it says, give the 3 quantum numbers that describes the 2s atomic orbital. Give the 3 quantum numbers that describes the 2s atomic orbital. So let's use 3 of the quantum numbers to describe the 2s atomic orbital. First of all, let's use the principal quantum number, that is n. So over here, n is equal to what? N is 2. This is the n value. Is that okay? Let's also use the L value, the azimuthal quantum number. What is the L value here? Our L value here is what? 0, because our 0 here represents the s orbital. Since the s orbital, our L value here is what? 0. Now let's also introduce the next quantum number as the ML. What will be our ML here? Our ML here is still 0. Why? Because the ML depends on the L. And how do we get the ML values from the L? We use the value range negative L to the positive L. Is that okay? Over here, our L value is 0. So we can't get negative 0 to positive 0, just 0. Is that okay? So our ML becomes what? 0. So the quantum numbers to describe the 2s orbital, our n is 2, our L is 0, and our ML is also 0. Is that okay? And that is the solution for question 3 as well. Alright, now let's move on to question 4. In question 4, it says, which quantum number distinguish the 3s and the 5s atomic orbital? So we have the 3s and also the 5s atomic orbital. Which quantum number distinguish between the two of them? Now let's break it down. What is the n value here? Our n value here is 3, and our L value here is what? 0. Our n value here is what? 5, and our L value here is what? 0. So with the two atomic orbitals, they have the same L values. 0, 0, because they are all s orbital, and s is what? The 0 for the L value. But look at the n values. It has n value of 3, and then n value of 5 here. So to distinguish between them, we use their n value. They have different n values, or different principal quantum numbers. Is that okay? So we use a different principal quantum number to differentiate between them as well. Is that okay? So the answer for question 4 is by using their n values or their principal quantum numbers. Is that okay? Alright. Now let's move on to the next question. That is question 5. In question 5, it says if ML has values of -1, 0, and then +1, we have to deduce the corresponding L value. Very simple. You can pause the video and tell the answer as well. So don't forget that ML depends on what? L. Is that okay? And which L value corresponds to -0, 0, and -1, 0, and then +1. That is what if L is equal to 1. Because if L is equal to 1, that is where we can have ML values to be -1, 0, and then +1. Is that okay? And that is coming from the value range -L to +L. So if L is 1, we can get -1, 0, and then +1. Is that okay? So the L value that corresponds to this ML values here is L is equal to 1. And that is the answer for question 5 as well. Is that okay? Alright, now let's move on to the next question. That is question 6. In question 6, it says if for n is equal to 1, what are the allowed values of L and then ML? So if n is equal to 1, what are the allowed values of L? How do we get the L value? We use the value range 0 to n minus 1. So n is equal to 1. So 1 minus 1 is what? 0. So 0 to 0 is still 0. Is that okay? So the L value for n is equal to 1 is what? 0. Now what will be the ML? We've done that already. It is still what? 0 as well. Is that okay? So that is the solution for question 6 as well. For question 6, our L value is 0 and our ML value is still 0 as well. Now let's move on to question 7. So in question 7 it says if L has values. So if L has values 0, 1, 2, and then 3. Deduce the corresponding n values. Deduce the corresponding n values. So again, how do we get the L values from the n values? That is by using the value range 0 to n minus 1. So let's assume that n is 1. If n is 1, 1 minus 1 is what? 0. So we have 0 to 0, that is still what? 0. Is that okay? So if n is equal to 1, that is where we get the L value to be what? 0. Is that okay? And that is the only orbital present in n is equal to 1. So for the first one, the L value is 0, the n value becomes what? 1. Now let's move on to another one. If n is 2, 2 minus 1 is what? 1. So from 0 to what? 1. So from 0 to 1 we have 0 and then 1. 0 is the S and then 1 is what? The P. So to get this P orbital, that is L value of 1, unless n is equal to what? 2. So it is when n is equal to 2, that is where we get the L value of 1. That is the P orbital present as well. Is that okay? Now let's move on to another one. If n is 3, 3 minus 1 is what? 2. That is 0 to what? 2. 0 to 2 is what? 0, 1, and then 2. Is that okay? 0 is S, 1 is what? P, and then 2 is what? D. Is that okay? So to get the 2 value for L, which is the D orbital, unless n is equal to what? 3. So it is when n is equal to 3, that is where we can locate an L value of what? 2, and that is the D atomic orbital. Is that okay? And now the last one, when n is equal to 4, 4 minus 1 is what? 3. And the value range becomes 0 to 3. 0 to 3 is what? 0, 1, 2, and then 3. What is 0? This is the S, 1 is what? P, 2 is what? D, and then 3 is what? The F orbital. How do we get the value of L to be 3? That is only when n is equal to what? 4. So these are the corresponding n values for the corresponding L values as 4. And that is the solution for question number 7. Now the last question. Now the last question for this lesson. The last question. In the last question we have complete the following set of quantum numbers. I have two sets. That is the first set A. In set A I have n is equal to 4 and then L is equal to 0. What will be the ML? They said you should complete the set. So what will be the ML? You can pause the video and tell the answer as well. Our ML will be what? Still 0 because the ML depends on the L value. Is that okay? And now in the second set, we have n is equal to 3, L is 1, and then what will be our ML? You can pause the video and answer the question as well. Our ML becomes what? Negative 1, 0, and then positive 1. Why? Because the ML depends on the L value. And then to know the ML, we use the value range, negative L to positive L. Our L here is 1, so it becomes negative 1, 0, and then positive 1. And that is our ML value as well. Is that okay? So please, these are the solutions to the sample examinable questions on quantum numbers in this lesson. Please, if you have any question, you can let me know in the comment section, or any further explanation, you should let me know. Please don't forget to subscribe to our channel for more lessons on the concept of chemistry. Thank you very much for being with me. We shall meet again in our next lessons.